Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with your Unit 2-2 homework over principles of work and energy. So number one, it says an athlete lifts a 280 Newton set of weights. So there's a weight given. Now in the one I have it says 280 Newtons. This is in red, which means your value might be different. Lifted a distance of 2.3 meters. And how much work is done? So work, okay, is force times distance. Anytime you're dealing with force, you need a free body diagram. I'm just going to use this, it says something about a weight. So it's going to be my quick weight here. You don't really need to put the person in it because it's about the weight, not the person. There's a gravitational force down, mg. Now in this example, the 230 newtons is a force. You don't need to multiply that by gravity again. The mg would equal 230. Then the person would have to apply some sort of force up. Now, even though this thing is moving in this direction, that doesn't really mean it's necessarily accelerating. If they're just kind of moving, in fact it says at constant speed, it is a non-acceleration problem. And that means the sum of all forces is equal to 0. All right, so that should be obvious how to get this force. And then you calculate work. Force times given distance, and that's pretty well it. So that'll definitely get you through number one, short problem. Okay, we'll chat. Let me get rid of this and we'll chat about number two. Okay, it says a box, 48 kilograms, pushed along horizontals with a horizontal force of 150 meters at constant speed. So first thing you do is draw a free body of the box. Well, really, first thing, a picture of the problem. All right, so there's a box being pushed, doesn't matter the direction. Let's make it go to the left here. So somebody is pushing on this with a force that's given in the problem. Mine says 150 newtons. Now I'm gonna, let's complete the free body. And it says at constant speed. Because it's at constant speed, there's got to be another force here to counteract that, if you will, and that hopefully is fairly obvious as a frictional force along this green surface. So let's put a frictional force in our free body. And then also a gravitational force. And then again at the green surface, an upward normal force. Now it's a constant speed problem, and that means that the net force is equal to 0. There's no acceleration here. Right, so that should allow you to pretty easily know what these two forces are, basically based on the free body. Now when it says what is the work done by the 150 Newton force, that's just force times whatever distance this box moves. I'll just call it d. Work is positive when the force and the velocity are in the same direction, so that's going to be a positive work term. Part B, where it says what is the coefficient of friction. So remember that the coefficient of sliding friction is equal to the sliding frictional force, that's what I want, is equal to the coefficient of sliding friction times the normal. You're going to get these from your free body, which will allow you to calculate that. So that should be not too big a deal. All right, I got to scroll down and look at number 4 here. Pretty much the same problem. Oh, I'm sorry. I already did number 4. Okay, so I guess I'm gonna just call that video done here, and I'll make another one. So I hope that helps with 1, 2, and 4. Okay, I'm gonna just call that good and make another, and have a great day.